Welcome to the next session on the research track. This is one I'm personally particularly excited about. This session is all about zk. And as our first speaker, we're very pleased to have Kostas Chalkias with us, who is the chief cryptographer at Listen Labs and has worked on free blockchain. So he was also the chief cryptographer at Facebook, back then Facebook, Meta. He is going to be presenting today zkLogin, which allows you to, in a privacy-preserving way, use existing credentials to authenticate. He came here all the way from Dubai, so please, a big applause for Kostas.
So I'm super happy here. I'm only for about 14 hours in the region, and then I'm going back to Dubai. The whole idea is this work took me 2 or 3 years to make it happen. And at the moment, zkLogin is the most popular zk application in the world, maybe even if we add all of the others together. And the reason is obvious, as you can understand. If you can snap sign in, if every sign in is with Google, Facebook, whatever it is, and then we do zero knowledge proof of that, practically for every user who logs into their wallet, you need zero knowledge. So it's not for all apps, it's not for all of the other things you will hear about today on zero knowledge generally. Let's go very quickly. The problem that we want to solve is UX and onboarding. There was a huge issue by the time all of the blockchain, infra, and the digital hype and everything started. Imagine myself working at Facebook, running some things on WhatsApp, Instagram, and so on. Then I said, okay, what's the major problem? Facebook tried to build a blockchain. What's the major problem of having the population, a big mass of the world to get into the space? Because it's a serious issue, right? We have many developers, probably there are researchers here, students, but imagine the average Instagram user. How can they have access to the blockchain? They don't even know what is a password sometimes, like a long password, and they don't know, in the blockchain, there might not be recoverability. You lose it and there is no, I'm sending an email, and they recover my password back to Google. So if you ask ChatGPT, it will tell you exactly the same. Look, the problem, that's the question, what's the biggest problem for the average user? In practice is onboarding. They don't know what the blockchain is. Sometimes we are using all of this like buzzwords and they cannot comprehend it. But the other thing is there is no good experience compared to what they're familiar with, the e-banking, everything that you have now in the Web2 world and so on. At the same time, you're asking them, oh, we have a campaign. For example, Sui is a sponsor at Red Bull. And obviously, Sui being one of the fastest blockchains, we wanted to have the fastest car as well and all of these things. And then we had a few campaigns for people to get NFTs. By the time you go there and you discuss with the Red Bull people, what is your audience? My audience don't know math. My audience can only watch cars racing and all of these things, right? We cannot go to them and tell, okay, look, this is your password, and from now on you have to put this to claim your NFT or send it. It's impossible. And imagine many people are not even native in English. If you ask them to put, I don't know, cinnamon or something else, saddle, nominee, double E, and all of this stuff, they will probably do it wrong. And because of all of this complexity, we said we have to find something else. There is the passwords that people are using. These are not good for private keys because they don't have enough entropy. The average person here are using something that technically, if I do some social engineering, I can probably figure out what your password is. And you are on the engineering or math, you are university students. Not all of the world is university students. So we said, okay, if we can get the mnemonics out, maybe we can improve onboarding. We can also improve discoverability and claimability. And I will explain what these two are. Now, if someone asks you, oh, can you send me some Bitcoin? Can you send me some Sui or Ethereum and all of this stuff? You tell them, look, this is a long address, 0x, blah, 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 A, B, 3F, and all of these things. It's impossible to remember it. And first, the second thing is you might type it in a wrong way. And at the same time, it looks more like an IBAN rather than using Revolut or Venmo, all of the other styles where you have a phone number and then you just send to someone by the phone number. So all of this might change if we had an easy way to authenticate and have an identity on chain. So one day, imagine at Facebook we were exploring this, there was no solution, then there was a situation where I personally traveled from the US to Mexico, And this is when this inspiration came. Obviously, I'm Greek originally, I was not an American, and when I crossed the border, they had to do some extra check on my passport. And then I said, okay, I need to find a certificate on the blockchain. There is no certificate. It's only passwords at the moment, mnemonics. And then when we went to the restaurant, they forgot to give me salt, and I will explain what is the salt and pepper and all of this in the protocol. And after all of these things, I said, okay, if we can find a way to use existing certification, add some salt there, like hide your identity and all of these things, and use some new technology which is zero knowledge proof, like the session of today, maybe we have a chance. But it was quite complicated, and you will see why it was complicated. So the basic solution that we were thinking is, look, people might be happy with their wallets. They might also be happy with someone keeping their wallet for them. So you log into someone with Google. This someone is a custodian. Custodian means I'm controlling the keys on behalf of you. And then after you authenticate, they sign for your transactions. But this model, as you can see, it's super centralized. Someone is owning your keys. It's the same thing with the banks. Again, I'm going back to my original, like where I'm from. In Greece, we had capital controls because I couldn't move my money for many months. It was very complicated. So custodians are a good thing when you have like a lot of funds and probably you don't trust yourself for your passwords. But for a hot wallet, it's very inconvenient. So then we said, okay, after all of this situation in Mexico, can we combine all of this together, see if we can somehow find something in Google, Facebook, Apple, what people are using, and convert it into a blockchain address? Because that would be great. Also, without linking your identity on chain. Because that's a plan, right? We have the other thing, you fight between the regulators of privacy. You have GDPR, MiCA, and all of this, and you fight against the other regulators who are for fraud detection and all of these things, that they don't want privacy. They want everything to be possible to analyze. So we were in the middle of a battle, and we were trying to figure out, okay, how we can hide everything, still you have access, and Google is not a custodian. Because that's also a trick. We didn't want to make Google a custodian. So now, if you log in with Google, I'm getting into the territory of engineers and people who are, I don't know how many people are engineers, but practically, this is what is sent back to the website. You log in, and then eventually you have, look, Google is using an algorithm, in this particular case RSA. This is the key, the certificate key that we're using as Google. And ISS is like the provider of this particular JWT. These two are happening to be the same, but it's practically the website. It's the identifier for the website. It can be the wallet in the blockchain space. This is a user. I added a few things here because it's an ID. The ID of the user. There is a situation where when you are claiming to log in with a website, they cannot see if you want, if you implement it correctly, your email. They can only see an ID. In this particular situation, we just hide the email. We didn't ask, you know, you have some permissions. When you log in with Google, this website will see your data, your friends, your email, your phone, and so on. The simplest one is they don't see anything, only an ID. So this is what we used, and there is also a notes. Take care of this thing, right? Because this was very important. And some expiration dates and all of this stuff. But this is a simple version of what you get in the background when you sign in with Google. Now we said, okay, we look at this. Can we do anything? We have a certificate. Somehow Google signed this because you get the signature over this stuff. But there is no private keys for the user. Someone can steal this information, even the website, and they can sign on behalf of you. And we don't want wallets to act on behalf of the users, right? We have to find another way. So practically what we did is we used these nonce here. The nonce is typically random information that every single time we're signing in with Google or Facebook, they're picking, their website is having a JavaScript library and is providing this to Google to defend against replay attacks. And this is a random value in practice. But then we said, maybe we don't use a random value now. What we do is the JavaScript is creating an ephemeral private and public key, and we put the public key here. So if every single time I'm opening the page and I'm signing in with Google, I'm creating in the storage of the browser or the wallet, if it's an app, of course, for more security, you're creating an ephemeral key, ephemeral. You can forget it afterwards. And if you forget it, you go and get another JWT. You go and log in with Google again. The website doesn't know about it in the wallet because it's happening in the front end. And also you can add expiration information even here. You can even get rid of the expiration things that you have here. which might be like something around your blockchain. Let's assume for 3 blocks, this public key, I own it. Only myself can put this information there. Do you know why? Because I'm the only person who can sign in with Google. Nobody else can do it. So the wallet, all of the wallets, you know, we trust them for the front end. Do you get this? There is no wallet that you don't trust anything. At least the front end, you have to trust it. So if you run this JavaScript, and this JavaScript now doesn't create a random nonce, and it's creating a private public key, and it puts the public key here, what do we have? It's a digital certificate. There is no difference between the digital certificates we have in our identities, passports, or whatever, and this one. But this one, you define the public. So the second thing is, can we put this on chain? Yes, please.
The nonce is very important. You said JavaScript, part of JavaScript is responsible for creating this. Whose JavaScript is that?
It's the wallet, it's the front-end JavaScript. Front-end, you always trust it. There is no way you cannot trust the front-end.
So if I say use zkLogin, the zkLogin library is JavaScript.
We're using a zkLogin library at the moment. In theory, the wallets can pick their own key generator, but we're providing, at least in SUI, because this is, yes, you see that SUI created this. Practically, this can be applicable in many things, or even applications on top of SUI. Technically, it can go to other bridges and other things, like someone from Solana.
I'm imagining that creating the public key and the authorization need to follow some standard.
Yes,
so,
but the wallets are doing this as well. When you go to the wallet and you pick these words that I said before, you're not picking the words. You know that, right? Why they don't allow you to pick the words? Because you're biased.
Yeah.
You will pick the easy words.
I understand.
This nonce is something what you get for return from Google?
No, you provide this nonce to Google and you say, look, I log in with my session or email and password, and I'm also providing you a nonce. Put them in a JWT and bring it back. So you decide, you as the user decide about the nonce, which is very important.
Just random, it doesn't have to be...
No, it's just a random information.
Your
Yes,
idea is essentially to change the nonce to public.
Yes, the idea is to put in the nonce something that is meaningful for the blockchain to verify eventually.
Then would it be susceptible to replay attacks?
Well, your wallet is creating a fresh key every single time you're signing in with Google.
Okay, so fresh public key.
Fresh public key. Every single time you sign in again, like you close your, you turn off your wallet, then you open it again, you want to log in, a new session, you are creating a new public key, you are signing in with Google, Google is putting your new public key here, and it sends it back to the user.
Then what is linking the public key to the...
And the identity.
To the identity.
This sub here. There is an identity of the user. It's not the email. Again, it's something better than email, but if you put this on the blockchain, some people can say, look, I know you are the user, blah, 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 blah. Maybe from another application I can link back to you. We don't want this to go on chain. And this is actually the meaningful meat, the source of this particular protocol. We had to do something else because we're linking now the identity with the nonce. And you don't want people to know that you are buying from Netflix or something else. You in particular as an individual. Yes, please.
Sorry. Yeah, many questions before the question section, but it's contextual. Don't you need to verify the RSA signature when it comes back? Because
yes, I will explain. We didn't reach this stage yet. Yes.
But here you're trusting, for example, Google that the sub will not change. I know it's part of the OpenID spec, but
yes,
if they decide to change it, then you
this is true. Yeah, SUI has a collaboration. This is true, but they don't change it. Google in particular, they keep it the same across applications for data collection. So even if I use wallet A and wallet B, the user ID will be the same. Facebook is not doing that. I was at Facebook, I know. Facebook is switching the IDs between applications to avoid the cross-matching. But you rely on this part.
Well, but Google will be able to block you if they discover that
they don't know the address. I will explain why they cannot link this JWT with the address, which is the interesting stuff. They don't know what to block. So one of the problems we faced is all of these questions you had. Right? Google can see my identity, the wallet can probably, now they cannot sign on behalf of me. If we put all of this JWT on chain, maybe between different apps you can infer who the user is and so on. Let's do something else. let the address be part of the user ID, but also add some salt, some random extra information. And this is provided by the wallet. So it's like a 2FA mechanism. Google is providing this, and the wallet is providing this. So practically, your address is more than just the user ID now. Because if it was just the user ID, someone can just brute force all of the addresses. Imagine, forget this. I can brute force all of the addresses until I find an ID that works. These IDs, by the way, they are long enough that brute force will be expensive, but it is possible. With the salt, it's not possible because the wallet or some salt provider, it doesn't need to be the wallet, can provide a random salt. And now you have a 2FA thing. The wallet and Google have to collaborate together in order to identify the user on chain. And that's the trick. Who maintains the salt can be many different stuff. I mean, we are using some MPC, TE. There are many ways to provide the salt as a committee that is providing the salt, but this committee cannot take over your account, which is one of the problems sometimes with wallets that are 2 out of 3 and all of these things. You need Google also to participate into this stuff. And we go to the next step. Can we snark it? Instead of getting all of this into the blockchain, can we get the address that we explained before, give us an input, the JWT signature of Google? This is now a ZK circuit, something that will happen in secrecy. And you will prove that all of this hold here. I verified Google's signature over a JWT. The JWT itself is a private input to the circuit. You don't want the prover, the verifiers to know what is a JWT, of course. You verify that the ephemeral key is injected into the JWT's nonce. You verify that the address is derived correctly, like the hash that we've seen before is getting from the private input the user ID, it's getting from the wallet the user salt, and that's why even Google cannot identify the address with the JWT because it doesn't know the salt. And now you're having the private and public inputs. The only public input that we want to have is the Google's public key should be on chain because the chain should verify that this actually came from Google. You don't want someone to impersonate Google. And also the user now is signing with ECDSA and TTDSA, right? Because we said, oh, we put in the nonce some public key, but blockchain transactions require a signature. The JWT itself and the zero knowledge is not enough to control your account. So the ephemeral key will be public, but every single time is switching, so there is no way you can get something out of it. And it's also just a public key, nothing else. Yes, please. So you need to be aware of the key rotation that Google does on its infrastructure. Yes, and we have our validators. For example, in Sui, that this is applied at the moment, the validators are pinging Google. They actually refresh it every month or so, and they have like a complete view of the current Google's public key. We have Twitch as well. Twitch never updated their key. Facebook and Apple, I don't remember if they do. But generally, the validators work as an oracle to be able to get all of the information from Google. And you can add, now that we have this, like zkLogin as a protocol, you can even build smart contracts and can have your own potential providers. Imagine you're Switzerland and you want to have your own provider, you will create a contract with zkLogin and then have a Swiss-based provider. It's not Google anymore. Because of the protocol is generic. Now, there were like all of these tricks that we did here, and eventually on the blockchain you do that. You verify zero knowledge proof, and you verify the signature from the ephemeral key. That is required now in all wallets. The extra step is this. Can you see, now we have a few cryptographers. Let's go to the next and let's go back here, so I don't have the hint. If we have cryptographers here, why don't you always need to verify the proof? I'm referring to you. Do you understand why? Do you know the zero knowledge proof is for verifying that the public key is now the ephemeral public key of my account for this session. I log into my wallet. Okay, let's go one by one. I log into my wallet and I don't want to sign a transaction. Do I need the zero knowledge proof? I'm just browsing. No, most people do that. They just browse their wallet. So now you can have a very lightweight proof. I mean, you don't need every single action to be a zero knowledge. The other thing is, You verify the JWT once, but before we said we have the expiration as well there. So if you're using your public key, you don't need again to re-verify the zero knowledge proof. So our validators, what do? They cast it. The first time they see a particular public key, they also cast the zk proof. So we have by far less verifications of zk bits. We might have proofs, but verifications are by far less. Now, if we ever have started these things, you see, we managed to make it easy for the blockchain that because SUI is also the fastest network at the moment. You couldn't be the fastest every single time you have to verify a proof. But with this trick, the users who are super active are not affecting the network at all. This is literally read the DSA signature every single time. And this cache is a big one. So people who play DeFi or games, they're actually not affecting the system at all. So that was literally like the full trick. And let's see in practice what's happening. Cryptographically, all of this that we have explained today is about 2 in the 20. 1 million constraints. Why 1 million? Because we managed to do, well, Google unfortunately is using SHA-2, and we have to verify, zero knowledge proofs typically require zero knowledge proof friendly primitives. So we have different hash functions if we want to use zk. But you cannot change the signature of Google. Google at the moment for JWT, they are still signing with RSA, and they are using as a hash function this. So we had to take this, and we couldn't avoid it. That implies that we had to improve the RSA verification because it's happening inside the circuit. Why? We said before, Google, we don't want even to check their signature on chain to figure out, oh, even if I don't know the JWT, maybe I will find my signature somewhere on chain and I will identify the user. So we put the signature in the JWT as well. For SHA-2, maybe you can do a few tricks to have some like lookups and other things. With Growth 16, it was not super easy. And to make this work, again, I'm getting back to my Facebook hat. You cannot have a login with Google, Facebook, Apple if it takes 3-5 seconds. People will not log it.
Sorry, I'm going to ask, does that have to, doesn't work on phone, I suppose, like it has to be on a centralized server, because I mean, less than 2 seconds for 1 million or 1 CS constraint.
Yes, at the moment they can delegate it. So we have people who are running committees to do the proofs. We had a few
but there's privacy with that,
custodians. Right? There is a way, by the way, to have 2 zero knowledge proofs where you hide in the first one the sub, and then the public blockchain, the public prover is doing only part of the operations. There are ways to hide this. I'm not saying we're doing it because now it's TE, it's like SGX and enclaves that are doing this stuff. But if you have an installed wallet, especially for laptops, RapidSnap is public. You can even do it with this. This is a max speed.
Yeah, but I'm not going to say. I'm going to talk to you later because
we at the moment we do have with 16 CPUs that are getting to the 2 seconds. As I told you, the 5 second is the barrier, right?
Yeah.
People who do it locally, and imagine, it's happening only once when you log in with your wallet. It doesn't really matter because the average behavior of a user is we are opening the wallet, we are browsing the wallet, and then we decide to make a transaction. There are seconds there where you can use these seconds in the background to run all of this information locally. Now, obviously this is Growth 16. Ideally, we want to find something else even in the future to do it locally, right? That's your eventual question, of course. Laptop-based wallets, I've seen them, they're not doing the delegation, they're doing it locally even with Growth 16. They might not achieve this, but this is irrelevant because they have an expiration of 1 day for their session. They do it only once, and then we forget about the ZK. By the way, from the ZK service, as you said, it's 278 for before the updates. Now it's even close to the 2 seconds. The signature verification, well, here it's the signature plus the ZKP. We had this discussion before with one of our attendees. It's about 2 milliseconds with 2 in the 20. Your examples are 2 in the 24, if I remember correctly.
Sorry, these 2.78 seconds that also involves the speed of the network because it needs to download the whole.
No, this is the verification of the validator side.
Oh, okay.
You're providing the Growth 16 proof. It has a.
Yeah,
there are a few public inputs. and 2 public inputs, I think. And as you can see, compared to the NDDSA verification, which is about 56 microseconds, it's how many times? It's like 40 times more expensive, right? To have the ZK compared to an NDDSA signature.
Yeah.
So anyway, that's how it works in practice. So this is the first version. It's not even the last one. So you just pick your email, done, you have an account. No passwords, nothing. And you want to send something, you submit send, blah, blah, blah. And then now, well, the transaction, this is real thing, and even before Mysticetti, because Mysticetti in SUI now makes a lot of things faster. But anyway, as you can see here, there are a few things that, because of the 2FA is not custodial, it's discoverable and claimable. How it's discoverable and claimable? At the moment with the user ID that we use, with the user ID that I have, it's, you don't know what user IDs of people. But the zkLogin protocol works with any identifier. If we allow the email, there might be future wallets. We don't do it for privacy reasons and other things, on SUI wallet at least, but there might be wallets that they use their email. For example, if you're Amazon, and you have the pay me at amazon.com and all of this stuff, you don't care about your email being closed or even being linked into all of these things, right? So people now can create an address for you. Do you know how they can create an address? You remember, I have the address at the bottom here. There is a wallet ID, and I might tell you, I'm sending you money. You never had an account on Google, on SUI, or Solana, or wherever this is used. Just use this wallet. Your user ID can be your email, and I will send you the salt. I'm texting you the salt. It's only you who can get the money, nobody else. And you go log in with Google, you will get your email in a JWT, you will have the proof, the salt, I gave it to you, I'm the sender of the money. So you can create one-time payments to people and they can go and claim it before they have an account. It's literally like Revolut today. I'm not sure, in Revolut, can you send money before someone has an account?
No.
Huh? Here you can.
You can send like a voucher or something. So
yeah, imagine that here you can do it. Technically, if you know someone's ID, they email, there is a wallet that works with emails, you send them the salt. You can even say, if this was Amazon, you don't even need the salt. It's fine for this to be linked. And you can send money to Amazon now. Amazon's addresses are identifiable by identity. If you want to hide the identity, you add the salt. That's the whole idea. And then what we did in SUI is we don't have the users pay more because they are using zero knowledge. I don't believe this. I believe this is a mistake of the blockchains, that you pay more because you're using multi-sig or you're using zero knowledge proofs. Does Google, like, I don't know, charges you more if you have a long password or a short password? Technically, they have to do more hash invocations if you have a very long password. But they don't do it, eh? So why the experience should be penalize people who are using ZK or they're using multi-sig or they're using all of this stuff? So we put zkLogin as a native authenticator. This doesn't exist elsewhere at the moment. I think one more protocol actually cloned what we did. But because of this, and you are not charging more, this is happening on the authentication, not on the transaction execution of the smart contract. The users are using it without being penalized, which is super useful. You can also do geofencing in theory. If you had a provider, someone is creating the zkLogin and say, look, the email, I'm creating another zero knowledge proof, that over the address I prove that you are .Brazil, or you are .Argentina, or you are .something. And technically you can have, I don't know, gambling websites or others that require some geofencing mechanism, where you can have some KYC plus identity, but without revealing the email itself. Because you can just prove your email ends at gov.brazil. So you can have these extra tricks that were not possible before. Now, discoverability and claimability, we explained this, and then it's reusable. Because it's a protocol. Now, the most difficult problem with all of the wallets that are MPC, that are social recovery and all of this stuff, if they go out of business, maybe you can recover, but now you have to find another solution. zkLogin is allowing all of the wallets. Who wants to build a zkLogin wallet in SUI? They can go and build it. It's like technology that is reusable. And now there is an extra benefit, and I've seen it many times. You lose your Google, go and find a way to recover your account in Google. Technically, now this is possible. I'm not saying it's the best one, and I typically use zkLogin even personally for my hot wallets. I don't know if I would put like 10 millions there yet. But because Sui is also supporting multi-sigs, what I'm doing is I do have an account which is on testnet, which is zkLogin or mnemonic. I have the mnemonic on my phone. Then if I, for some reason, Google goes down, at least I can go grab my mnemonic and recover my account. So that's all. Thanks everybody.
Thank you very much. Maybe we have time for one quick question at the end, if someone wants to ask.
Yes, please. First there, here, let's see if we have time. Otherwise,
Just a
in
quick
the
one.
corridor, yeah.
Yeah,
Yeah.
so my question is about the salt. So as I understand, if you use different salts with your email address, you can basically have multiple
Yes,
wallets.
this was also an important thing, like BIP32 on Bitcoin,
Yes.
right? Because some people want to have multiple addresses with the same login. Just change the salt.
Yeah.
Or you can have the salt, then the other salt is hash of the salt, the other is 2 times hash of the salt, or you have a counter, (0, (1, (2, (3). So you have one salt and you can have multiple accounts. This was also a benefit of this construction.
Okay, yeah.
Because in some other places, you remember like the first one very quickly, if you go to the custodian, you only have one account.
So there's no this like a hierarchical structure to actually to help you to rediscover this account, to rediscover this stuff.
If you have one salt, you can derive all of the other salts.
Yeah, but there's no like in your protocol. There's no way actually to define like Bitcoin, this 80 wallet actually define all the different level of salts.
Well, as I said, hash of salt, (0, (1, (2, (3, (4, 5) is the way to yes to recreate all of them.
If you lose the salt or the provider loses the salt, then your account is gone.
Yes, that's why we're using TEs in this particular case. The user is storing it on memory sometimes, and they reuse it again. Or they use a multi-sig, as I told you before. Or there is a committee for the salt. It's not only, it's a 2 out of 3 for the salt now. But now the committee cannot sit on you. The worst thing they can do is somehow they go out of business and you don't have access to your account, but they cannot get your Google ID. Okay, we're done, and I'm taking other questions like in the corridor here. And
Yes, I think you're around for today and tomorrow still. So
Yes,
if you
please.
have more questions, I think Kostas is probably happy to answer them. And maybe another round of applause.